4, 3, 2, 1.
So for my part is I have to do a data arrangement for the transshipment in Penang Port from 2017 to 2019. So I sort out all the data of the 12 months in 3 years. Then I have to do a frequency distribution using the first step, which is determine the number of classes using the formula 2 power of k more than n. So in this case, the n is equal to 36. So I use 2 power of 6 to get 64, which is more than 36, and k equal to 6. Therefore, the number of classes is 6. And then I use the second step, which is determine the class width, which is using the formula max entry minus minimum entry divided by number of classes. After I got all the class width, I make a table with frequency in it, which is first class 11 frequency, second class 23 frequency, and so on. And then I have to find a midpoint, which is using the formula lower class limit at upper class limit divided by 2. Then lower boundary, I use the formula of lower limit minus by 0.5. And then upper boundary, I use the formula upper limit at 0.5. And then after I got all the data about the midpoint, lower boundary, and upper boundary for all the classes, I put in a table. After done with that, I have to do a relative frequency, which is I have to use a formula which is f divided by x equal to 1. And the last one, I have to do a cumulative frequency by adding up the frequency from the past class. 11 at 23 equal to 34 for second class, 34 at 1 equal to 35 for third class, and so on.
Good morning, madam and my fellow friends. My name is Kang Hui Zhen. My metric number is A19A0208. I will continue explain graphical method. The graph that we are using is frequency polygon and ogive. A frequency polygon is a graphical form of representation of data. The graphical polygon was quick by using the midpoint and frequency that calculate from the data. The ogive is defined as the frequency distribution graph of a series. In this ogive, the horizontal axis uses the upper class boundaries and vertical axis uses cumulative frequency.
Hi, my name is Kang Willie. My metric number is A19A0160. Next, I will explain the measure of central tendency. Measure of central tendency can be defined as a value that represents the center of distribution. There are three most commonly used measures of tendency for good data, which is mean, median, and mode. I will explain mean. Mean is sum of a data entries divided by the number of entries. The mean can be calculated using the following formula. So we can get the mean, which is 5228.7.5. Next, I will explain median. Median is the value that lies on the middle of the data when the data set is ordered. The median can be calculated using the following formula. We have 5 steps to find median, which is step 1, determine the location of the median class. Step 2, determine the lower class boundary of median class. Step 3, determine class width. Step 4, determine cumulative frequency before median class and determine frequency of the median class. And the last step, which is step 5, calculate the median by using median formula. So by using the step above, the median is 5103.3261. Next, I will explain mode. Mode is the data entry that occur with the greatest frequency. The mode can be calculated using the following formula. We have also 5 steps to find mode, which is step 1, determine the location of the model class based on the highest frequency. Step 2, determine the lower class boundary of the model class. Step 3, determine class width. Step 4. Determine the difference between the frequency of model class and the frequency of the class before model class, and determine the difference between frequency of model class and the frequency of the class after model class. And the last step, which is step 5, calculate the mode by using the mode formula. Therefore, the mode that we can get is 52615.0294. That's all for me. I will pass to my friend. Thank you.
Good morning to my lecturer and my fellow friends. My name is Divya, daughter of Marifan, and my metric number is A19A0115. Today I would like to explain about measure of position. In this part I will explain about first quartile, third quartile and interquartile range. The first step is identifying the location of first quartile and third quartile by using formula. Therefore, the location of first quartile is 9th position and location of third quartile is 27th position. After that, I had found the class interval based on cumulative frequency. Therefore, the class interval for first quartile is 30,016 to 46,719 and the class interval for third quartile is 46,720 to 63,423. The second step is find the value of first quartile and third quartile by using formula. The value of first quartile is 43,682.4091 and the value of third quartile is 58,339.6739. Finally, I found the interquartile range, which is third quartile minus with first quartile. Therefore, the interquartile range is 14,657.2648.
Next, measure of variation. First, we calculate the range. The range is the difference between the highest and lowest values in a set of numbers. Therefore, the range is about 100,000 and 222. Then I will explain that variance and standard deviation. Before doing calculation, we should create a table which include class, midpoint, frequency, S squared, Fs and Fs squared to get sum of total. Variance defined as the average of the square difference from the mean. The equation of sample variance is S squared equal to 1 divided by n minus 1 and then multiply by bracket, which is the sum of total Fs squared minus sum of total Fs in square bracket divided by n. Answer is 215,246,789.5. For sample standard deviation, its equation is square root of the variance. Therefore, the answer is 14,671.2913.
Now I would like to explain about shape of distribution. The shape of distribution is skewed to left based on mean, median and mode. In this case, the value of mode is higher than the value of mean and median. That's all from me. Thank you.
Good day, madam and my team members. My name is Kailuli, daughter of Ramchandran, and my card metric number is A19A0211. Today I'm going to talk about the analysis of XPSs. First is measure of central tendency. The difference between manual calculation and XPSs output for mean is 483.75 and the median is 651.3261 and mode is 22599.0294. Second is the measure of position. The first quartile is 937.4091 and the third quartile is 907.6739 and the interquartile range is 29.7352. The median difference in first quartile, third quartile and interquartile range show that the result get from manual calculation is not same. The measure of variation, the difference between manual calculations and XPSs output for range is same, which is 100222 minus 100222, so equals to 0. Variance is 418,857 to 0.6 and standard deviation is 1364.06059. The range same as the XPSs output. The shape of this distribution is skewed to right, which is based on our mean, median and the mode. The mean is 51803.75 and the median is 51152 and the mode is 316. which is mean more than median and the median is more than mode. In this assignment, we use the decision rule using p-value as the method to identify whether the null hypothesis will be rejecting or fail to reject. The significance level or alpha is set as 0.05 in this ANOVA analysis. We will reject the null hypothesis if significance or p-value is less than 0.05. Index is referring or trend shipment. For the trend shipment, the significance value is 0.00. Therefore, we reject the null hypothesis as the significance value is less than 0.05. For the month, the significance value is 1.000. Therefore, we fail to reject the null hypothesis as the significance value is more than 0.05. Next is correlation analysis. There is a moderate positive correlation between year 2017 and 2019, and the R value is 0.670 upon the R value between year 2017 and year 2019 is 0.670, which is less than 0.85. Perhaps there is no problem of multicollinearity. Meanwhile, there is a weak positive correlation between year 2017 and year 2018, and the R value is 0.050. The R value between year 2017 and year 2018 is 0.050, which is less than 0.85. Perhaps there is no problem of multicollinearity. For this research, we have set the confidence interval by 95%. Thus, our significance is 5%. For year, the confidence interval range are from 1.7198 to 2.2802. After that, the model regression of summary. The R-square value is 0.196, which means 19.6% of the variation in population can be explained by year 2017, 2018 and 2019. The p-value or significance value from the ANOVA table is less than 0.05, which means that at least one of the three variables which are year 2017, 2018 and 2019 can be used to model as month. Then the coefficient for every unit increase in year 2017. Months will drop by 0.001 provided year 2019 remains unchanged. The significant value for year 2017, 2018 and 2019 are less than 0.05. So year 2017, 2018 and 2019 are not the significant predictor of months because it's more than 0.05. Finally, the test of normality. The Sharpe-Weill test of normality on the ratio rules give a p-value of 0.066, which is more than 0.05. Thus, the assumption of normality of the rescheduled terms is met. And that's all from me. I'll pass to my friend and thank you.
In conclusion, for this assignment, we go apply the knowledge of statistics that learn from classroom and learn in YouTube for doing the task given, especially ways to download IBM SPSS statistic format. We also work as a team and overcome all the obstacles together in order to complete this assignment. We feel satisfied after complete this task as we have good teamwork and communication between us. Thank you.